Hi everyone. In the earlier videos, we have discussed what a linked list is, how to create a node, how to traverse the nodes and display the data, and also how to insert a new node at various positions, at beginning, at end, at specific position. So in this video, I am going to explain the delete operations in a linked list. So that is delete at beginning, delete at the end, and delete at a specific position. So first step is deletion at a beginning, deletion at a beginning. So if you want to delete this first node, what we will do is, if you delete this node directly, uh, how to assign the head to the corresponding node. Okay, so for that I am going to use the help of temp again. So for that I am going to use the help of temp. So this is temp, suppose this is temp. So you will write one line, temp is equal to, this is self dot head, self dot head, temp is equal to self dot head. Automatically temp is referred to the head, first position. So temp is point to the first node. Okay, now what is this self dot head dot next is, what is this self dot head dot next is 1200. So that is, this 1200 also refer to temp dot next is equal to 1200. So now this head move to this position, this head is moved to this position. For that what I am going to do is self dot head is equal to 1200. But how to write 1200? You are not supposed to write directly this address here. We don't know what is that next node. Okay. For that, you already have an idea about the temp, because temp is equal to self dot head. So temp dot next is, this is next field. Temp dot next is 1200. So simply you will write here temp dot next. Then automatically the head change it to next node. This is self dot head, this is self dot head, but still there is the address of this node here in the temp dot next. So this will change it by write an instruction here, temp dot next. We want to remove this address by replacing with none. So what happened here, automatically this is none, and automatically this link is cancelled. So in this way you have to create, you have to delete node at the beginning of the linked list. Now deletion at end. So this one, how to delete this one? So to delete this last node, so traveling is must to last node. How to travel? Again, as usually we will use with the temp, but here we also used previous. So for that I am going to delete these values. So now again I am going to use two variables, one is temp and another one is previous. So previous is simply self dot head. I am going to traverse with these two variables help. So whenever this is self dot head, automatically it will point to by the previous. So this is my previous. My temp is this one. Next, this one is my temp. So how to represent this temp is simply, this is self dot head dot next. Here this is the address of this node. So I forget to change this. Yeah, 1200. So self dot head dot next is 1200. So you will represent this temp by self dot head dot next 1200. So 1200 is now pointed to the temp. So here you will write self dot head dot next. Self dot head dot next is 1200. 1200 is nothing but temp. So this is temp and previous. Okay, we will move these two variables to next nodes. Okay, what we will do is, we have already an idea how to move this one is temp is equal to up to this node, temp is equal to temp dot next. Similarly, previous is equal to previous dot next. So up to run by using the while loop, while temp dot next, while temp dot next is not none, not none. Check, temp dot next is 1300. So it is not none. Now temp is equal to temp dot next. Move from this place to this place. Now previous is equal to previous dot next. So previous dot next is 1200. So now previous will move to here. Okay. Now check, while temp dot next is not none, temp dot next is 1400. It is not none. So temp is moved from this place to this place. This is our temp. Now previous is equal to previous dot next. So previous dot next is moving from the this position to this position. Now again verify, while temp dot next is not none. Yes, temp dot next is 1500. This is next. Remember. So temp dot next is 1500. It is not none. So temp is equal to temp dot next. So again temp dot next is 1500. So go to this temp here from this position to this position. This is our temp. Again next step, previous is equal to previous dot next. Now previous will move from this point to this place. Now again verify, temp dot next is none. Yes, exit from the loop. So now we will remove this one. How to remove this one? Simply, this is our previous dot next have some address. So after the loop you will write one statement, previous dot next is equal to, simply you will put none. That means automatically this 1500 will move here, none will replace, then link will cancel. Automatically this node will be deleted. Okay, this is deletion at end. Now coming to the deletion at position. Deletion at position, third one. Deletion at position. So now I am going to delete this one. Now I am going to delete this node. What is that node? 30 14. So this one I am going to delete. Again with the similar way, we will use the two variables. One is temp, that is already I told you, self dot head dot next. Same in similarly what we have done in the deletion at end. So now this is previous is equal to self dot head. So this one is previous, this one is temp. Okay, previous is equal to self dot head. Yeah, again you will write same steps. Temp is equal to temp dot next, previous is equal to previous dot next for I in in range of 1 comma position minus 1. Okay, so I am going to remove this third one. So what is that? Position is equal to 3. So what is the range? 1 comma 2. So if I is equal to 1, what happened? I is equal to 1. So temp is equal to temp dot next. So what is this temp dot next is? Temp dot next is 1300. So now temp is moved to 1300. So from this place to this place temp is moved. Okay. Next one, previous is equal to previous dot next. So change this previous one, this node to this node. Now I is equal to 2. So here 1 is less than to execute, but 2 is less than to come out from the loop. Immediately what we will do is we are going to delete this node. Now simply if you observe here, previous dot next is 1300. Now I am going to change this 1300 with 1400. How to change this 1400 here? So for that here I am going to write previous dot next. Now what is previous dot next is 1300. Now I am changed it to the 1400. But how to write this 1400? You are not supposed to write directly this address here. We don't know what is this node. Simply we know the node because this is a temp dot next. Because 1400 is, this is temp dot next is 1400. So automatically what happened here? Temp dot next, if you write like this, then this 1300 is removed, this 1400 is replaced here, then directly the link is created like this 1400. But still there is some temp dot next is 1400. You will remove that one by using temp dot next is equal to none. That's it. Temp dot next is none. So now we will implement the code in Python. So in the earlier videos I have written this code already, insert beginning, insert and insert position. Now I am going to write one more function here. Before going to write this function, here I am going to create one more node, that is n5 is equal to node of 50, enter. N4 dot next is equal to n5. If you want to check the display, run. Extra I have to create one more node 50. Okay. So next, now here I am going to write define function name delete underscore beginning self. Okay, now this is delete at beginning. Now I am going to write here temp is equal to self dot head. Now self dot head is equal to temp dot next. next temp dot next is equal to none. That is delete at a beginning. Now define delete underscore and self. Okay, same. If you check it here, same code you will write here. So previous is equal to self dot head, temp is equal to self dot head dot next. So write while loop, while temp dot next is not none. Okay, so temp is equal to temp dot next, previous is equal to previous dot next. So outside you will write previous dot next is equal to none. That is deleted and now we will write delete at a particular position. So define is equal to delete underscore position self comma position. So we will pass the position parameter must and should. So now write what is this here, write the steps simply. Initially temp previous is equal to self dot head, temp is equal to self dot head dot next for I in range of 1 comma position. So again temp is equal to temp dot next, previous is equal to previous dot next. Outside of the loop you will write previous dot next is equal to temp dot next and temp dot next is equal to finally make it as none. So this is the implementation part. If you want to verify it, here you will call one by one. First I am going to call delete at beginning. First of all I will run this one. This is okay, yeah, this is initial. Now I am going to call this delete at end, delete at beginning. So copy this one, control C. Here you will write s sll dot control V. Now run. See 10, the node 10 is deleted here. Okay, node 10 is deleted, it is beginning. Suppose if you remove this one and change it end, check it, run module. Now node 50 node is deleted at the end. Suppose if you want to change position, yes, position third, if I am going to move third, now run, change the to yeah, 30 has been deleted. If you give the position here, here I forget to give position minus 1. Okay, now you will give 3, then you will get the same output. Yes, 10, 20, 40, 50. Okay, position minus 1. Then only you will delete the node exactly. Okay, position minus 1. So with this, I will stop this session. In the next session or in the next video, we are going to discuss about the double linked list. Okay, thank you.